Hey everyone, welcome to Tellor Community Call, October something, early October, October 5th. Okay.
I didn't trust my instincts.
Yeah, really exciting day. Today we're going to do our Tellor X code walkthrough. Some initial announcements on some things. As you guys, some of you are following the Ample4th piece, should be kicking off to a governance vote here soon. It's the word on the street. So get your fourth tokens ready. Go vote for us. Should be a nice clean integration. Don't know what that actually means for timelines and integrating as far as like when it actually goes live, but we'll be voted in.
And their fourth has to be out of any centralized exchange.
Yeah, so if you're holding,
before it starts.
yeah, so if you're holding fourth, make sure you also pull it off of like a centralized exchange, similar to like whenever you're voting with TRB. If you're holding your TRB on a centralized exchange, you can't vote with it. So make sure, as you should always, hold it in your personal wallet.
Did you say it has to be in your own wallet before the vote starts?
Yeah, so similar to, they're using snapshot voting, which is,
Yeah.
Similar to like how Tellor, they look at a snapshot of one block and then take it. So, and that's to kind of prevent you from voting with one account and transferring it.
Yeah.
So, other than that, hackathon's still going on. A lot of people building on Tellor, some cool stuff. If you need some more ideas, you need any help, definitely feel free to reach out to us. Other things on the dev side, the new Telliot coming along great. We'll actually do a code walkthrough with that probably in a few weeks. And then little housekeeping announcement before I hand it over to Mike. Next week, there will be no community call on Tuesday. We'll probably move it to like Thursday or Friday because it is, we're bringing the whole team up. So we'll have a lot more of us here in the office, so it'll be fun.
One thing we could do, regardless of if the team's all in person or not, and I was going to propose this before you said that, but we are ready to do a walkthrough of the new Tellor X website / front end thing. I think it'd be really cool to have Ben or Ryan do a walkthrough.
We can do that on Tuesday.
And that won't be too long, so we could do that with the whole team in person anyway. So
cool.
Yeah, that's our big update this week, is that we're moving. We've sort of nailed all that down. We're ready to share it with you guys. I know I've been talking about it for a couple weeks now, but we're excited about it. And yeah, that's it. Let's hand it over to Tim.
Tim, so the floor is yours. You have as much time as you need. Ryan, if you want to let him share, and yeah, excited to see what you got.
Okay, and just so everyone knows, if anyone has any questions as I go through this, feel free to cut me off. And then also, if there's any questions at the end, hopefully we'd love to hear them. So I'm actually going to share my screen. Okay. All right, so we are going to start with the Tellor master contract. This is the main master contract of the whole Tellor system. And this is already deployed. It's already being used by Tellor 3, and it is not new with Tellor X. But this is a contract through which we'll be doing our upgrade. And so the master contract delegates its calls to, in Tellor 3, a Tellor contract. And as we'll see in a minute, in Tellor X, it delegates its calls to the controller contract. So let's look at the controller. Or actually, first let's look at the Tellor storage contract, which, like master, is already deployed. It is also not new with Tellor X, but it handles the storage of lots of different variables in the Tellor system. It holds information about disputes from Tellor 3, and about information on requests. Also, as we'll see shortly, we'll be moving the storage data, the dispute data and Oracle data to their own contracts in Tellor X. But the storage contract, the storage exists at the Tellor master address, and it'll still be using many variables in Tellor X and TRB balances, allowances, etc. So moving on to the controller, where again, the master delegates calls to this controller contract. The controller handles changing the addresses of the different contracts in the Tellor system. It also handles minting and migrating old TRB to the newer TRB. And I'll just note that there will not be a new TRB token for Tellor X. This is just for migrating the very old TRB tokens to the somewhat less old TRB tokens. So the controller has a few functions for changing contract addresses, and these functions can only be called by the governance contract. And governance calls these by going through a proposal and a vote, which we'll see in a little bit here. But here you can see it has functions for changing the controller contract, governance, the Oracle, the Treasury, changing some uint variables, and migrating and minting TRB. The controller inherits from Tellor staking and transition. And basically that means that everything in the transition and Tellor staking contracts, all of that is actually in the controller. There's not a separate Tellor staking or transition contract. So first, let's look at the transition. Transition is used to create a smooth migration from Tellor 3 to Tellor X. So it links to the Tellor 3 Oracle data and Tellor 3 data disputes. And it has some functions for retrieving values from the Oracle. So as we'll see down below, some of those functions for retrieving values, they will first try and see whether the value exists in Tellor X. And if not, it will try to look for that value in Tellor 3. So basically transition just allows any parties that are already using Tellor to continue using Tellor as they were before. And so here we can see some functions for getting different variables in the Tellor system, address variables, some information about disputes, and here is one function, get last new value by ID, which uses the logic I mentioned before. It'll first try to find a value in Tellor X in the new Oracle contract. And if it can't find it, it will look for that value in Tellor 3 in the older data. And further down below, we have some more functions for retrieving data that use similar checks for finding Tellor X data or Tellor 3 data. And at the bottom here, you can just see where transition gives access to multiple functions from Tellor 3. So let's say in Tellor 3, some miners dispute or submit some values, and then we make our upgrade to Tellor X, and then someone wants to dispute one of those recent Tellor 3 values. That can still happen, still through the Tellor master address, which delegates that call to the controller for the transition. And then, so back to the controller real quick. Remember, controller inherits from transition, like we just went over, and it also inherits from Tellor staking. So let's look at the Tellor staking contract. This staking handles the logic for Tellor reporters to deposit their stake and become a reporter. And it has some logic for reporters to unlock their stake. So here you can see the deposit stake function, which is what's used by a user to first become a reporter. So anyone who wants to be a reporter has to have 100 TRB in their account, and then they can call deposit stake, and then they'll become a staker or a reporter. And then once a reporter wants to no longer be a reporter and retrieve their tokens, they can call request staking withdrawal, and that begins a lock period of 7 days. And during that time, people can still dispute the reporter's data, and their stake is still locked up, so the disputer can still claim the stake after a successful dispute. And then, so if a reporter has requested a withdrawal and the waiting period has expired, then they can finally call withdraw stake to actually claim their stake. In this contract, there's also a /miner function, which is only called by governance in the case of a successful dispute. And then we also have stake info functions, a given staker.
So Tim, ask some questions. I noticed you do, since we went through like everything that inherits in the controller, which is the fallback, I noticed you do the staking on the current Tellor address, correct? But the reporting will not be on the current Tellor address.
Right, yeah, that's a good point to bring up. Yeah,
how do you see, and I saw there were some reading functions. So like, you know, you can get last new value by ID and things like that, that would be in kind of the using Tellor portion. How do you see people kind of using it? Do you see a lot of people going directly to the Oracle contract, or do you see them all still reading from this master?
Well, I think existing users of Tellor 3, they have a high chance of continuing to use the existing master address. Obviously, anyone who has who's using Tellor data within a contract that's already been deployed, that can't be upgraded. They have to use that same logic, which is great. They can. the controller and the transition contract, when you're calling data or retrieving data from there, it's actually converting that data to uint values. And also, when you are retrieving data from there, you're inputting a uint value as a request ID. So anyone who's still using uint values could definitely still use the master address. But since Tellor X is moving to using, let's see, bytes 32 values for the IDs and bytes values for the actual data for the values, anyone who's using those bytes and maybe converting them to something other than uint 256 values, I think they would want to use the Oracle contract address, just because at the master address, that value will be converted back to uint values.
Sure. Awesome. Thanks, Tim.
Yeah. And then, so controller inherits from Tellor staking. Tellor staking inherits from the token. So let's look at the token contract, which contains some of the normal logic for ERC20 tokens. You can see it has, you can read users allowance. We also have the allowed to trade function, which tells you whether a user can transfer their TRB. So in the case that the user is a reporter with 100 TRB staked, that user cannot transfer their TRB without first unlocking it and going through the correct process. And also, if a reporter has been disputed, their tokens are locked. So this allowed to trade tells you whether a user's TRB can be transferred. We have some more standard ERC20 functions. There's also the balance of at function with an input of a user address and a block number. So we use checkpointing for the TRB token, and that is used for any votes. So when someone creates a dispute or someone creates a proposal, we take a snapshot of everyone's TRB balances. So when users vote, we look at the user's balance at the time that the vote was initiated, or the dispute or the proposal was initiated. And that prevents people from transferring their tokens to different addresses and attempting to vote multiple times with the same token. And then, yeah, we have some more standard ERC20 functions. So we've just gone over the controller and everything that is inherited by the controller, and also the master. And since the master delegates calls to the controller, we can think of everything we've just gone over as kind of all coupled together. And then, so next we'll move on to the Oracle, which is not quite as coupled with everything we've just gone over. It still is controlled by the controller and by governance, but it also is kind of standalone in that it has its own storage. And like Nick just mentioned, users can interact with the Oracle directly through this Oracle contract address. So the Oracle contract handles the logic for tips and making a data request, and for reporters submitting values. So let's look at the add tip function. Tellor we've had this add tip function, but in Tellor X, there are some updates to it. First of all, you can see the Bytes 32 ID value, which is a new thing where we used to use uint 256 values. Now, for any existing request IDs, so like request ID 2, before you would use 2, and those values will still be mapped to 2, which is if you convert the uint value to Bytes 32. Then that is where request ID 2 values will reside. And then we have the tip amount. And then finally, we have the Bytes data argument, which is a new feature in Tellor X. This argument is going to be used for the new Tellor X data specs. And basically, this is Bytes data, so it's open-ended. It can be basically any length, and it can contain different types of data converted to bytes that can be converted back to other different types of data. And this data will be used by reporters to fulfill requests when just the specification of a request ID isn't sufficient. And also this data will only be emitted in an event, in this tip added event, and it will not be stored on chain. So that saves some money on gas by not storing all that data. But since it's in an event, it is still available to reporters who want to fulfill a request. So for example, if we have some sort of a bridge standard in Tellor X, where the reporters need to know the sender address and the token address and maybe a token quantity, someone can request that Tellor reporters submit data to Ethereum network, bridging tokens from Polygon, for example. So the reporters need to know which user address is allowed to unlock some tokens. They need to know what token address is being transferred and what token amount. Those might be some examples of values or data that would go in this Bytes data field. So that's a new feature in Tellor X. Here you can see the change mining lock function, which can only be called by governance. We'll see shortly in the governance contract the process by which this type of function can be called. So let's see. So here we go. And by the way, the mining lock, at least for now, is 12 hours. So that is the amount of time that a reporter has to wait after submitting a value to submit another value. And by the way, if any reporters want to submit more frequently, they can stake at another address, another 100 TRB. So then from that address, they can submit another value. And then, so below change mining lock, we have change time-based reward. Again, only callable by governance. Remove value is also only able to be called by governance. Okay, next we have the submit value function. This is the function where reporters will be submitting their values. And again, we have the Bytes 32 ID, the Bytes value. So that Bytes value is more open-ended than UINT 256. It could represent UINT values still. It can represent strings, bytes, all sorts of things. So that will allow Tellor X to support many more different types of data, different types of applications. And the third argument in submit value is a nonce value. And that is a new feature in Tellor X. So the purpose of the nonce value is to prevent someone from wasting gas on a request ID whose reward has already been claimed by someone else. So if someone adds a tip for a request ID, two reporters both see that and want to report the value. If the first reporter submits the value and the second reporter submits the value at similar time, without a nonce value, the second reporter would waste money on gas. But with the nonce value, that transaction will fail and the second reporter won't waste their gas money. And then down here we have some getters for the Oracle contract. So you can see, you can get the current reward. So this will return how much of a drip reward is available, and also how many tips are available for a given request ID. And we also have some getters for retrieving values from the Oracle. Some information about reporters and reports. So that was the Oracle contract. Next, let's look at governance. And so the governance contract handles disputes. So if someone wants to dispute some value, and governance also handles proposals for changing different parameters in the Tellor system, for changing contract addresses. So here we can see in the constructor, governance is deployed with a whitelist of functions that are allowed to be called by a proposal. So these functions are some of the functions we've already seen in other contracts. Like we just saw change mining lock in the Oracle contract. There's also a function, set approved function, for adding new functions to this whitelist. And all these functions can be called by creating a proposal, which we'll see below. But first, we have the begin dispute function. So if someone wants to dispute a reporter's value, they can input the request ID and the timestamp. So in order to dispute a value, the user must have a TRB balance. Now that dispute fee depends on some conditions. So the more disputes there are on a given request ID, the higher the fee is. The more disputes there are ongoing in general, the more the dispute fee is. And also, when someone does call this begin dispute function, 10% of the dispute fee goes to tip the request ID that's being disputed. So the intent of that is to incentivize someone to quickly add another value to this request ID, since some value in that request ID has been made unavailable by the dispute. So after someone has successfully called begin dispute, a dispute is active, and then let's go down to the vote function. So TRB holders can call this vote function to vote on the dispute. They input the dispute ID and the bool value, whether or not they support the dispute. And there's also the option of choosing invalid query. The invalid option is only available for disputes, and it is not available for proposals. But for a dispute, sometimes things can be hazy. Sometimes you could have a highly volatile day in the ether price, for example, and it can be unclear what the correct price should be at a given time in that day. So we don't want to discourage reporters from submitting data on volatile days or in other hazier conditions. So if a vote resolves to invalid, then the reporter gets the stake back and can continue reporting again. And the disputer gets the dispute fee back minus the 10% that went to a tip. So then after the dispute voting period is over, which is 2 days, then someone can call tally votes. And so for disputes, there is a 0 quorum. And this tally votes function is going to figure out what the outcome of the vote was. So if most people voted invalid, then the vote will resolve to invalid. And if it's mostly in support, then we'll go in support, etc. And then after tally votes is called, there is another waiting period in which someone can dispute the outcome of the dispute and start another voting round. In order to start another voting round, someone will call begin dispute once again, and input the same parameters of the original dispute. So once we finally pass the waiting period after tally votes, which is 1 day, then someone can call execute vote, which will look at the outcome of the vote, and if the vote passed, then execute vote will slash the miner and give the stake to the disputer, the first disputer in the first round. And it will also give that disputer the dispute feedback. And if there are multiple rounds on this dispute, then the other disputers will just get their dispute feedback. If the dispute resolves to against, then the reporter will get the dispute feedback, and the reporter will get the stake back, and will be able to continue reporting.
One quick question, Tim.
Sure.
It seems like most of the dispute mechanism seems pretty similar to Tellor 3, outside of the invalid inquiry option, which is cool. Is there anything else that's like notable? Or it just seems like the dispute mechanism was pretty good as it was.
No, you're right. It is very similar. Yeah, actually, off the top of my head, I can't think of any other big difference other than invalid.
I think the other thing to note, like if you had complaints about the current dispute system, it would be that like we wish there was an invalid. We sort of realized that, and then it's really expensive to dispute, and we're hoping that gets fixed as well, right?
Right. Yeah.
So
And since
yeah,
we're lowering the stake amount, I think you can logically lower the cost to dispute and take someone's stake amount.
Yeah, I think that was like a big hesitation for people, and now in submitting disputes is that it's a month's salary to go try and dispute. It's probably even more. It's a lot of money to go and dispute somebody. So if we can lower it now, it's similar to the last one. It's based upon the number of stakers in the system. So if we get more stakers because we're lowering the amount and adding in some incentives to get more stakers, then the stake amount or the dispute amount will lower down to like something like 10 TRB, which will be way more affordable. Like even for us, like it's feasible for a lot of people to get 10 TRB to be able to submit a dispute. So we're not too concerned about that.
Right. Yeah. So we want people to be able to dispute bad values, but we also don't want people to be able to attack our system and try to hang it up. So that's why as there's more disputes active, then that cost goes up. So we're trying to deal with those trade-offs.
Yeah, and then how much is it to propose a vote to like upgrade?
That is proposed vote. What was that?
It's 410. It's 10.
There it is.
Yep. Well, and then so this was, we have there's also a quorum in here as well, which you're probably going to go over, I would assume. I think this is probably different than a lot of other systems. Like if you look at like Uniswap, it costs, a year's salary or something like that to propose a change or any sort of these upgrades. So we wanted to keep it sort of affordable, and at the same time, you don't want too many because it costs money to vote these things down. People are trying to spam your system, but yeah.
Yeah, so how much is that?
10 TRB.
And then as the number of active vote rounds goes up, then that 10 TRB gets multiplied by 2 to the number of vote rounds. So yeah, there's a distinction between disputes and proposals. We just went through disputes, and then this proposed vote function is used to create a proposal. So the arguments for this function would be the contract. That's the contract address where the function resides that we're going to call. The bytes for function identifier. So this would be from that whitelist we saw in the constructor. There's a bytes data argument, which would be the arguments that go into the actual function we're proposing to call. And then there's a timestamp argument, which is used basically for identifying a unique proposal. And so when someone wants to challenge the outcome of a proposal vote, they can call this proposed vote function, and they have to make sure they input all the same parameters, including this timestamp. So then from here, it's a similar process to the dispute process. Once again, TRB holders call the vote function, and they input the ID and true or false whether they support the proposal. But in this case, there is no invalid outcome, so this invalid argument is ignored. And then after the voting period, once again, someone can call the tally votes function, but in the case of a proposal, the vote period is 7 days, whereas in a dispute, the vote period was 2 days. And then for a proposal, there's a quorum of 5% TRB supply. So tally votes determines the outcome of the proposal vote. And then there's another waiting period, which is 1 day for proposals as well. And then, so in that time, someone can challenge the proposal vote and put it up to another vote. And then once the waiting period successfully passes, someone can call execute vote, which will call the whatever function was being proposed to be called if the vote passes. And so that is the main functionality of the governance contract. And again, this contract has some getters, which allow you to retrieve some information about disputes, about voters. And
Did I miss that? Oh, sorry.
Go for it.
Did you show the delegate function that voters can delegate their vote?
oh, right, I did not.
Okay.
Good point. Yeah, we also have this delegate function. So TRB holders can delegate their voting power to some other address. So we, the Tellor team, could vote on behalf of people, or anyone else could.
Question, is there a default delegator?
I don't believe so.
There isn't. I'm just quizzing you.
Yeah.
Uh,
The answer is no.
but this is, so a lot of systems, some of them will have where you're automatically delegated to somebody unless you take it back. And you know, we decided against that. So, and then can you delegate, and then can that person delegate everybody's votes?
Can a delegator delegate?
Can a delegator delegate?
No, we do not have chained delegation.
Why not?
Well, I guess we technically could, some people do, but it gets messy. It gets expensive chaining lots of delegations.
It'd also be lame if everybody just ended up delegating, and I feel like it would just reach the top of the pyramid eventually, and there would just be one person voting.
You also, yeah, because that was my biggest thing, is you lose a little bit of the feel of it. You know, like you want to trust the person you're delegating to. You don't want to like have a delegate of a delegate of a delegate. Like, what is this? You know, you want to make sure that they can't sell your votes as easily.
Oh, right. So yeah, that's the governance contract. And then we can move on to the Treasury. Now, this contract handles buying and issuing Tellor treasuries. So basically, Tellor governance can vote to issue some treasuries quarterly or really whenever they want. And then if that vote passes, then TRB holders are able to buy the treasury, which locks up their tokens for a period of time. And as you'll see, as long as they vote, as long as the Treasury investors vote in Tellor governance votes during the Treasury duration, then they'll get the full Treasury return rate plus their initial investment. So the Treasury life cycle starts with a proposal, a governance proposal, like what we just went through in the governance contract. That proposal would propose to call the Treasury's issue Treasury function, which has a few inputs: the max amount, which is the maximum amount of TRB that can be locked in this given Treasury. There's the return rate, which is the maximum amount that the Treasury investors can earn for investing in the Treasury. And then a duration, which is a timestamp of when the Treasury funds can be unlocked. So once governance calls issue Treasury, there will be an active Treasury available for TRB holders to purchase. And so TRB holders will call the buy Treasury function, inputting the Treasury ID and the amount that they want to purchase. Remember, there's a limited amount of TRB that can be purchased in a given Treasury. So once the user buys the Treasury, their TRB amount is locked until the Treasury period expires. Now, once we reach that expiration date, anyone can call this pay Treasury function. It has the inputs of the investor address and the Treasury ID. So once again, Treasury investors are expected to participate in voting during the time that they're invested in the Treasury. So if an investor participates in 90% of the votes that occur during their Treasury period, then they'll only get 90% of the Treasury return rate when they call this pay Treasury function. And then anyone who participates in all the votes will get all of the return rate plus their initial investment. And then this Treasury contract has some getter functions for retrieving some information about Treasury investors, about a given Treasury. And that is basically the Treasury contract. So that's basically the whole Tellor X system. Once again, we went over Tellor master and the controller and everything that the controller inherits. Like I said, those are all kind of coupled together. And then we also have 3 more contracts that are kind of standalone, but also are controlled by the whole Tellor system, by governance and by the controller. We went over the Oracle, governance, and the Treasury. And that's it.
You guys want to say something?
Yeah, so Tim, on the Treasury,
Yes.
when they buy a Treasury, do they actually get a token? How does that work?
Oh, yeah. They do not get a token, no receipt token or anything like that.
Why not?
Yeah. Well, why not? It's a good question. I mean,
Well, the main reason is that we want the tokens to be out of circulation, so they're gonna be out. They shouldn't be circulating, basically. And
Right.
also, yeah.
but even though they don't get a receipt token, they can, let's see, they can retrieve some information about their investments from Get Treasury account, inputting a Treasury ID and their address. So that will tell them how much they've invested in a given Treasury. They can also see the total amount that they have in all treasuries with Get Treasury funds by user. So there are a few ways that investors can keep track of the treasuries they've invested in, see how much they have invested.
Awesome.
Cool. Well, Tim, this was an excellent walkthrough. Thank you for taking us kind of through all the code and the various contracts. If anybody else wants to go through this and in any more detail or has any questions, definitely just let us know. We're excited for those of you that don't know, the Tellor X is currently out at an audit. We've gotten a lot of feedback. He just our auditor actually just feeds us the feedback as he finds it, and we've implemented most of the changes. We should be getting that back next week, and then we'll share it with you all and make any final changes before we deploy it on Rinkeby for full testing. So, yeah. Anything else, guys?
Great job, Tim.
Yeah, good job.
Thank you. Thanks for listening.
Cool.
Anyone who listened.
Yeah, and there's a pretty extensive testing suite in this thing as well. So if you want to go and poke around any of the tests to see how it actually works, it's another work of art, I would say. So cool. Well, anyone else? Thank you guys very much for coming on. Like we said, we'll let you know if we're gonna have a call next week or what we're gonna be doing. But yeah, thanks for hopping on and talk to you guys soon. Bye.
Good job, Tim.